Now, question is that suppose n bombs are required to completely destroying the target. So, now if we bomb, if we n bomb you are throwing, then what is this random variable can be represented by x1, x2, xn. So, each bomb actually each xy defined as, it is nothing but 50% chance that it strike the target. This is equal to half for I is equal to 1 to n. As earlier we discussed that these are all Bernoulli distribution, all are independently distributed random variable and all identically distributed, though all have the same probability mass function. Now, we will show that then we know that x1 plus x2 plus xn, this is nothing but So, this is nothing but binomial distribution in probability 1 by 2. Now, for destroying the target, what is required? The required is that 2 direct hits are required. So, that is why this y actually it is a binomial distribution. The probability that y is equal to small y, that means this is the probability mass function that it will hit the target, 2 target up to out of n bomb, how many bomb actually hit the target, this is the small y. This is probability is nothing but we know that this is n c y p to the power of y and 1 by 1 minus p whole to the power n minus y. Here p is 1 by 2. So, y is equal to 0, 1 to n, this is equal to 0 otherwise. Now, this can be simplified as n c y 1 by 2 whole to the power n, because this is the advantage whenever it is a probability is half, we can simplify in this way. So, this is nothing but otherwise. Now, to destroying completely 2 hits are required. So, that means it is asked that how many bombs must be dropped to give a 99% chance or better to completely destroying the target. So, completely destroying target we need at least 2 hits. So, to completely destroying the target, we need at least 2 hits, at least 2. So, that is it is given in this information must be dropped. So, completely destroying hardware required hits are required 2 direct hits, at least 2 direct hits. So, the probability of at least 2 direct hits is, so at least 2 direct hits means this probability should be y should be greater than equal to 2. So, that means y is the random variable, how many hits strikes bomb, how many bombs strikes out of n bombs. So, at least 2 means it may be 2, it may be 3. So, now because this n we do not know, so that is why it is nothing but probability that y is equal to 2 plus probability of y is equal to 3 plus probability of y is equal to n. So, now it is a probability mass function, the sum should be 1. So, this is nothing but sum of all the, if we take sum of probability y greater than equal to 0, this should be equal to 1. So, this is nothing but 1 minus probability that y is equal to 0 minus probability of y is equal to 1. So, basically we can write this event as a in a more simplification. So, this is directly we can write 1 minus complement of this event y less than 2. So, this is nothing but 1 minus probability that y is equal to 0, y is less than 2 plus probability of y is equal to 1. So, that is the two probability here we have to compute only. So, that is why now this probability it is asked that this probability should be greater than equal to 99%. So, that is why whenever it is greater than equal to 99%, sorry. So, whenever it is greater than equal to 99%, this probability, then we have to solve that how many bombs we will find, because it is greater than equal to 99%. So, let us find out this probability first, probability that y is equal to 0 plus probability that y is equal to 1. So, now how we can find this? So, this is nothing but probability of y is equal to 0 is how we will find, this is from this expression NCy. So, NC 0 1 by 2 to the power of n, this is the probability that y is equal to 0 plus y is equal to 1 NC 1 1 by 2 whole to the power of n again, because this is the 1 by 2 here same. So, this is nothing but this is NC 0 is 1 1 by 2 whole to the power n, this is 1 plus this is n, this is the probability. Now, this probability it is asked that find this is asked that how many bombs must be dropped to give a 99% chance or better to completely destroying the target. So, this is the 99%, this probability should be greater than equal to, that is why 99% or better. So, hence this probability of y greater than equal to 2, this should be 99% 0.99, which implies 1 minus probability of y greater than equal to 2, this will be less than equal to 1 minus 0.99, which implies this is nothing but probability that y less than 2. So, this is less than equal to, this should be less than equal to 1 minus, so this is 0.99, so 0.01. So, basically we can write as a fraction. So, this is nothing but 1 by 100, 1 by 100. So, now this probability we have found here, this probability is nothing but this is the probability of y less than 2, this is probability less than 2, this probability. So, which implies, so this implies 1 by 2, this implies what we got, probability of y less than 2 less than equal to 1 by 100, probability that y less than 2 less than equal to y less than 2, probability of y less than equal to 1 by 100. So, which implies y less than 2, what we are finding, what is this, y less than 2 is nothing but this is y less than 2 we found 1 by 2 whole to the power n 1 plus n. So, less than 2 less than equal to 1 by 100, which implies 1 by 2 to the power n 1 plus n should be less than equal to 1 by 100. So, then it is nothing but 2 to the power of n is greater than equal to 100 plus 100 n. So, that you have to solve. So, because it is not a linear equation, so we may not, so that you have to just check different values of n. So, some of the values, suppose if n is equal to 1, then it is nothing but 2, it is not satisfying. Similarly, you can increase the n values. Now, if you know that if you take n is equal to 10, then this value we know the 2 to the power 10 is 1024, whether this is greater than equal to this value 100 plus 10 into 100 into 10. So, this is 1000. So, this is 1100. So, this is not just missing few values. So, that is why if you take n is equal to 11, this will satisfy. So, this n is equal to 11, 2 to the power of 11 is greater than equal to 100 plus 100 n. So, it is asking minimum number of bomb. If it is n is anything greater than equal to 11, then it is actually n is equal to 11. So, into 11 you can see this is satisfying this relation. So, if n is greater than equal to any value 11, then also this will satisfy plus 100 n. So, in that case we will mention that the at least n is equal to 11 number of bombs should be hit to get the thrown to get the at least 2 hits with minimum 99% of probability. 2 direct hits are required to destroying the target completely. So, how many bombs? So, at least 11 bombs must be dropped to give a 99% chance to or better to completely destroying the target. So, I hope you have understood this concept in binomial distribution, how you can use binomial distribution for solving this kind of numerical problems. Now, we will discuss Poisson distribution, other important distribution. So, we completed Bernoulli distribution and binomial distribution. Now, we will start discussing some other important distribution. So, these two distribution you have seen that the range of the random variable for Bernoulli distribution is 0 or 1. Now, for range of the distribution for binomial distribution is 0, 1 to n. These are finite number. Now, we will discuss another distribution. This is also a discrete random variable. The range of this random variable can be infinite, but it will be countably infinite. So, a random variable x is called a Poisson random variate with parameter lambda greater than 0 if its probability mass function is given by this relation. So, now let us write down this. So, a random variable x is said to have Poisson distribution with parameter, there is a parameter here Poisson distribution, like Bernoulli distribution parameter is p, it is belongs to 0 and 1, closed interval 0 1. For binomial distribution we observe that there are two parameters, one n is a integer, positive integer, and p is again 0 1, and here for Poisson distribution the parameters are one parameter only, lambda. This is a real number, but it will be greater than 0, less than infinity. So, with parameter lambda belongs to open interval 0 to infinity, if the probability mass function of x, is given by, so this probability mass function we can write Px of x, this is nothing but e to the power of minus lambda to the power x by x factorial, where x is 0, 1, 2, like this. This will be equal to 0 otherwise. So, now what is e? You know that e to the power x has some kind of this expression 1 plus infinite series x plus x square by 2 factorial plus x cube by 3 factorial, like this. So, it has this kind of expression, whenever x is any real number, for any real number. So, you can check that it is always greater than equal to 0. This is a probability mass function, and if you take the sum of this probability mass function, this should be in the real line x is equal to 0 to infinity. So, this is nothing but summation of x is equal to 0 to infinity. So, e to the power of minus lambda to the power x by x factorial. So, now this is nothing but, see, e to the power of minus lambda we can take common. So, summation of x is equal to 0 to infinity lambda to the power x by x factorial. So, these things you know that this is nothing but this kind of expression is there. So, x is 0 to infinity, here I have taken. So, this is nothing but e to the power of minus lambda, x is equal to 0, this is 1, then this is lambda plus lambda square by 2 factorial plus lambda cube by 3 factorial, like this. Now, see that this expression, this is looks like very similar here. So, this is nothing but e to the power of lambda. So, e to the power of minus lambda into e to the power of lambda, this is equal to e to the power of 0, this is equal to 1. So, that is why it is a probability mass function. Now, what are the values? If you take, suppose x is equal to probability that p x, this is nothing but probability that x is equal to x, this is nothing but e to the power of minus lambda, lambda to the power x by x factorial, whenever x is 0, 1, 2, like this. This is equal to 0 otherwise. So, now if you take x is equal to 0, p x 0, this is nothing but probability that x is equal to 0, this is e to the power of minus lambda, lambda to the power 0 by 0 factorial. So, e to the power minus lambda. So, lambda is any value, lambda can be suppose 3, then it will be e to the power of minus 3. So, lambda is any value in the real line. So, it is a some number you can consider 0 to infinity, it is a parameter, depending upon the lambda it will be different value. So, p x 1 will be nothing but probability that x is equal to 1. So, e to the power of minus lambda, lambda to the power 1 by 1 factorial, this is lambda. So, similarly, so you can denote like this is nothing but p 1, p 0, this is nothing but p 1. Similarly, we can denote. Now, if you draw this curve to understand it, this is this random variability 0, 1, 2, like this, 3 like this. So, at 0 this is nothing but this p 0, then this is p 1, this is p 2. So, like this. So, p 3. So, whenever it is actually has you can observe. So, different values of lambda, if you find out the probability. So, then you can see that this will be the probability. So, it is called a mode also, where it is maximum probability, it will be around lambda, it will be maximum. So, if it at this, according to this curve, the lambda may be close to 2, because it is maximum, it is going increasing, then it will be decreasing, like that. This should be, this curve looks like this, it will be a unimodal distribution. Unimodal means, mode means one mode only, mode means where it is taking the maximum. So, this curve, it looks like that it is increasing, then decreasing, like that. So, that is why it is a mode here, and it is a unimodal distribution. Now, how you can find the cumulative distribution function from this for this Poisson distribution? The cumulative distribution function, so CDF of a Poisson random variate is given by, so this is nothing but f of x x, this is probability that x less than equal to x. So, we have already discussed how we can find cumulative distribution function from probability mass function. So, this is nothing but whenever what is the minimum value, this is minimum value is 0. So, it will be 0 less than this, and whenever it is less than greater than equal to less than 1, this will be nothing but p 0. So, we have already discussed in binomial distribution cases also. So, then whenever it is x is greater than equal to 1 less than 2, then this is p 0 plus p 1, like this it will continue. So, for any I greater than equal to x less than equal to I plus 1, this is nothing but p 0 plus p 1 plus p I, like this. So, it will be converging at infinity, because this is, it has infinite range. So, that is why it will be the, if you draw the this curve, this is this, if you try to represent it from graphically. So, this CDF looks like this is x, this is 0, 1, 2, 3 like this. So, this is 0 here, then it will be some value here, then this it will continue. So, this is continue like this, and suppose this is 1. So, it will be converging at infinitive. So, this is actually, so it will be converging at, so it is like this is this y axis equal to 1, this line will be asymptotic of this kind of function. So, f x x. So, because f x x will be goes to 1 at x whenever x goes to infinity, it will not be any finite value, it will not be exactly 1, there will be some probability remaining to close to 1. So, that is why this is a infinite range, this random variable has a infinite range, countably infinite range of this random variable. Now, this Poisson distribution, how we can find the mean and variance, some of the important measure. So, let us find out that. So, the mean of this random variable mu 1 dash, this is expected values of x. So, how we will find that? By definition, this is nothing but x k p x of x k. So, what are the possible values it can take? So, now here this possible values is nothing but summation x equal to 0 to infinity x, p x k is nothing but e to the power of minus lambda, this probability mass function you can see, this is the probability mass function we have to write here, e to the power of minus lambda, lambda to the power x by x factorial. So, now we just have to compute it. So, simplify these things, this is nothing but summation. So, x equal to 0, this is 0. So, that is why this is 0 plus summation x is equal to 1 to infinity x. So, e to the power lambda, e to the power of minus lambda, lambda to the power x. So, x factorial we can write x into x minus 1 factorial. So, this is cancelled. So, then finally, e to the power minus lambda is independent of x. So, how we can solve this? This is nothing but e to the power of minus lambda summation x equal to 1 to infinity. So, lambda to the power x by x minus 1 factorial, that what we can do, we can write lambda to the power x minus 1 by x minus 1 factorial. So, now this how we can find this, because it is an infinite series, we have to use some kind of known series, so that we know it is a convergent, and also what is the value of the convergent series. So, what is the sum of this series. So, then lambda it will be independent of x. So, lambda e to the power of minus lambda. Now, x equal to 1 to infinity lambda to the power x minus 1 by x minus 1 factorial. Now, x minus 1 factorial, these things we will take this transformation, suppose r is equal to lambda minus 1. So, then you can see that the minimum limit it is x, sorry, r is equal to x minus 1. So, r equal to x minus 1. So, x minus 1. So, this variable I am changing this variable. So, x is equal to 1, it is the minimum of this range. So, x is equal to 1, then r is equal to 0. So, this will be nothing but r is equal to 0 to, and x goes to infinity, r also goes to infinity. So, then lambda to the power r by r factorial. So, then if you can lambda e to the power of minus lambda, r is equal to 0 1, then plus lambda square by 2 factorial like this. So, then you will, this is nothing but you can see that this is a infinite series of this kind of 1 plus lambda square by 2 factorial, it is nothing but it will be converged to e to the power of lambda. So, that is why this is nothing but lambda e to the power of minus lambda, then e to the power of lambda. So, this is nothing but lambda. So, that is why mean of this Poisson distribution is nothing but the parameter lambda. Now, we will find what will be the variance. So, for finding the variance we need second order moments. So, because you know that sigma square of x variance of x, actually variance of x, how we can find. So, variance of x can be found by definition, this is x minus mu 1 dash whole square. So, which is the simplified form we will use here, this is nothing but mu 2 dash minus mu 1 dash whole square. Now, what is mu 2 dash? Mu 2 dash is nothing but expected values of x square. So, by definition expected values of x square is nothing but summation of x square p x of x k over k, if you take the sum over k. Now, what is x square here it is taking? It is nothing but the x equal to 0 to infinitive. So, this is nothing but summation x is equal to 0 to infinitive x p x x. So, p x x is here we will write the probability mass function of this Poisson distribution. Probability mass function it is p x x is nothing but e to the power of minus lambda, lambda to the power x by x factorial. So, e to the power of minus lambda, lambda to the power x by x factorial. So, this is x square, x square, x square. Now, similarly we can use x is equal to 0, this is 0 plus summation of x is equal to 1 to infinitive x square e to the power of minus lambda, lambda to the power x, x factorial we can write x into x minus 1 factorial. So, then this 1 x cancelled, but till another x is there. In that case you cannot more cancellation you cannot do. So, this similar way you cannot simplify here. You can see that here x cancelled. So, we got a comfortable some convenience for getting this kind of transformation, but here because there x is there. So, we cannot do this similar computation here. So, because in the denominator we cannot get another x here. So, we can get x minus 1